Hey folks, Professor Finn here, and today we're going to be looking at the embalming dilution formula. This was a question sent to me by one of my students, and it seems just about every time I teach an embalming course, someone will reach out and say, "Hey, can you explain that embalming formula? I don't quite understand what's going on. Can you walk through it with me?" So we're going to walk through four different questions, and we're going to explore where do you go wrong, how can they hide some things in some places, so that you are better prepared to answer these questions. So let's go ahead and get started. So let's talk a little bit about what the equation is. With any algebraic formula, the letters are placeholders for numbers, and we have to understand what these letters stand for. So there are two sides to the equation. There's a bottle side and a tank side. Some professors teach it with the tank on the left, the bottles on the right. That doesn't matter. Neither does the letters that are used. So the way I learned this, for instance, was C times V equals C prime times V prime. Another professor I collaborated with, his professor taught him C1 times V1 equals C2 times V2. Again, does not matter. These are placeholders. So what do they stand for? And I'm going to go the way that I learned this with the bottles on the left. And that's the concentration of the bottle times the volume of the bottle is going to be equal to the concentration of the tank times the volume of the tank. So how does this fit in? Well, we don't generally refer to concentration of the bottle. We use a special word in funeral service for this, and that's called the index of your arterial fluid. Okay? So the index of the arterial fluid is equal to the volume of the bottle, which in generally we measure the bottle in ounces. And then the concentration on the tank, which is usually a percentage of some sort, okay, is measured or is multiplied by the actual volume of the embalming machine, which is generally measured in gallons. So couple things you need to understand here. First is we need like for like when we're doing math. So the first thing is, what is index? It is a percent. We always measure index in a number. That number is relative to a percent. So we're good right here. We have a percent and we have a percent. Then we have ounces, we have gallons. That is a problem. So we have to convert either gallons to ounces, or in my case, ounces to gallons. I did have a peer I went to mortuary school with, always loved converting the ounces to gallons, so it would be gallons to gallons. It would look like this. That's not the way I learned it. It's not the way you're likely going to encounter it. You're probably going to encounter it like that. And there are 120 ounces per gallon, and we'll also mention that there are 16 ounces per bottle. So we're going to keep those things right there. So now that we understand what the letters stand for, we understand the breakdown of each side of the formula and some of the common conversions that we need to do when we have to do things like for like, we can start looking at a question. So let's look at this one. You are preparing to embalm a female Aleutian decedent who is 160 pounds. Now, sometimes the description can come into play, but we're not going to focus on this right now. Let's look at the other stuff first. Using 4 bottles of a 22 index humectant in a 2-gallon embalming machine, what will the total percent solution be? Well, we pretty much have everything we need. Whenever we do this formula, we must have 3 of the 4 different variables. If we don't have 3 of the 4, we can't solve. So one of the ways you can approach this is, what is the known unknown variable? What is it that they're actually asking for? So it says 4 bottles of a 22 index humectant, 22-gallon embalming machine. Those are given numbers. What will the total percent solution be? So we now know that our variable, our x, is going to be the total percent solution from the embalming tank, which means we have to have 3 other numbers. Do we have them? Using 4 bottles, okay, so we have 4 bottles. We're going to let Excel do the heavy lifting here. Using 4 bottles of an arterial humectant, which is 16 ounces per bottle times 4, 64, okay. 22 index, so this is going to be 22 index in a 2-gallon embalming machine. what will the total percent solution be? So now we have to make sure everything is like for like. Well, the first thing is we have ounces here, right? 64 ounces. We need ounces here. So that is going to be 128 times 2, 256. We have gallons here. We have gallons here. Life is good. We have an unknown here. We need this in 22%. And remember that percentages, when expressed mathematically, look like this. There's always going to be the decimal and then the numbers, or if it's a 2%, it'll be like 0.02. The only time we see something like this is with 100%. A percentage will equal 1. So this becomes important when double checking your math. So we do not know what the percentage over here. So let's start with the math we do know. And when you are doing this on a board exam, you will be doing this with your scratch paper in your writing utensil. So you will not have a calculator. You must be able to do this on your own. For sake and clarity and you seeing how things work and the fact that I don't have a touchscreen computer where I can just write on the thing, we're going to let Excel do the heavy lifting for us today. So we're going to multiply our 22% times our 64 ounces, and that gives us 14.08. On this side, we're going to get 256x. And we are now in a algebraic equation. We're going to solve for x. And the way we're going to do that is by dividing this number by 256. So we have x equals to 0.055. Remember, we're solving for a percent. So this number right here is a percent that we must now probably convert to an actual percentage. So we do not have 0.055%. We have 5.5%. And now we have to see, does the math work? So we already know that this number, or that cell, whoops, something happened here. Forgot the parentheses. This number times this number will equal 14.8. And now we have to double check. Does this number multiplied by this number equal the right thing? And we see we have a problem, do we not? Well, let's try to fix something here and see what is going on. That is really odd that Excel is doing this to us because, and this is just simple math, if we were, the issue is, of course, that this is making a percentage automatically because I had a percentage sign in there. So what we need to do is we need to format the cell to nothing more than general or a number, and we see that the math works. So this would not be something you would encounter in a board exam. This would be something you encounter because we're using Excel. So 14.8 equals 14.8. The math checks out. If we did something completely different, right? So if I did the math completely wrong, this would be a far different number. This is why you want to double check. So for instance, instead of just using the percentage, let's go use, so you saw what it looked like at 5.5. You can see it's a completely wrong number. If we go ahead and we use the 0.055, we get the right answer. Professor Finn, how did you know that was wrong right off the top? God, you're so smart. No, I'm really not. I know that 10% of 256 is going to be around 25. So if I'm getting a number that is extremely astronomical, I have something wrong, and I need to figure out what that is. In this case, it was simply a programming issue with Excel defaulting to a percent cell. So Is this, some valid science? Yeah, it's not bad. 5.5, it's a fresh body, that's pretty high. But fact of the matter is, we are not asked to give our opinion whether this question is practically usable. We're simply solving for the math. And that's a very important thing that you understand, that when you are given a variable like this, you are not being permitted to make adjustments, whether you think the 5.5 is too high or whatever. You simply answer the question. So let's look at another one. Okay, so the next question. You are preparing to embalm a male Asian decedent who is 200 pounds and exhibits livor mortis. The body is exhibiting the onset of rigor. If you only wish to use 4 bottles, what index arterial fluid should you use to create a 3.0% solution in a 2.5-gallon embalming machine? Well, what do we know? What is our X? What is the variable we're looking for? What index arterial fluid should you use? Well, that's a concentration, so we know that that X has to go here. Do we have the rest of the variables? If you only wish to use 4 bottles, okay, so we're only going to use 4 bottles. That's given to us whether we like it or not, 64. We want to create a 3% solution in a 2.5-gallon embalming machine. So we have to do our conversion. 2.5 times 128, it's going to give us 320. And now we do our math. We know we have a 3%, 64, so we know this is going to be 64x. Lucky us. And we'll just move that over here to the right, because why not? And then we're going to do some math over here. At least Excel is going to do some math for us. And we see 9.6. Okay, so let's isolate the x. This number divided by 64. And we have 0.15. So is this right? Let's double check our math. Let's put 15% here. Because remember, this is a percent. 0.15 will be 15%, not 0.15 index. Let's do our math. 9.6 equals 9.6. And a quick way for me to isolate this is in Excel, I can force it just to look at certain cells by adding dollar signs. So I know this math is correct. I can just copy paste that there. 9.6 equals 9.6. Looks like my math is right. So we're looking a 15% index, 4 bottles to create a 3% and 2.5 gallons. Would this be something that is usable? So you're preparing to embalm a male Asian decedent who is 200 pounds and exhibits livor mortis. The body is exhibiting the onset of rigor. Well, now we have a problem, right? So there is this old rule, which is pretty good. It's a rule of thumb, which is for every 50 pounds, you should inject 1 gallon of appropriate preservative solution. In this case, we have a 3% solution, which is higher than normal, and we're putting in 2.5 gallons. So if we do the math, we need about 4 gallons of a regular. Can we go a little bit higher and reduce total quantity? The answer is yes, we could probably do that. Do we want to do that with a 15% index? Well, that might be one of those academic questions you can have some fun with a professor. But given what you're given in the question, you must do the math according to what you're given. And you have some livor mortis, onset of rigor, which means the body's been dead between, probably about 3 and 6 hours. You could probably get away with this, probably get some good cosmetic value. You don't have a really bad case. But I would probably err on the side of caution and maybe go up to a higher index if we were doing this in an actual embalming environment, which is why you want to check your math. That, hey, maybe this is a bit light and I need to change something up just a little bit. So this is why this exists. This is why we do this formula. So when you are answering your board question, You must answer given the criteria you are given. If you can identify that, hey, maybe this is the wrong idea, good for you, but that doesn't help you with boards. Do not change the number just because you feel you need to be using a higher index. So make sure you're always just answering the question and moving on. Which brings me to a good point. When you're doing a computation question, try to save your analysis, application, computational questions for the end of the exam. Answer all the multiple choice questions, the multiple answer, the true and false, the point click go, not more than maybe 30 seconds tops on a question, and save the large ones for last. That way, if you do start having a problem with time, you are not getting wrecked because the clock ran out and you're only a quarter of the way through the test. If you answer 3/4 and the last quarter of the questions are analysis and application, well, even if you don't get to answer them, you've still answered at least a good majority of the exam. And people do have negative experiences with board exams because they run out of time focusing too much on one question. So point, click, go, then go back and review the questions and work on questions that are more time consuming, like the ones we're looking at here. Because remember, you're going to be doing this by hand. So if you're doing this by hand, it will take longer. Let's go on to the next question. Okay, so what do we have? You're preparing to embalm a male Caucasian decedent who is 170 pounds and exhibits moderate livor mortis. Post-mortem caloricity shows the body's been dead a minimum of 3 hours. No rigor is evident. You have the following chemicals on hand: an 11 index jaundice fluid, an 18 index humectant fluid, a 32 index fast firming fluid, 22 index cavity fluid. Using the best index for this case, how many bottles of it would it take to create a 2.5% solution in a 3-gallon embalming machine? So, a couple of things here. You are given a lot of data. This is definitely one of those questions that you just, okay, cool, move on to the next one, and you keep going until you've finished everything else, and now you're going to come back and spend time on this, because this is going to take some time. For a person like myself, I can pretty much identify, what's going on and where to go with things, but for the student, you're likely going to want to take a breath and look at this. So the first thing, don't bother with the distractors yet. Go with what we already know. So using the best index for this case, how many bottles of it? We're looking for bottles. So we know this is X. Would it take to create a 2.5% solution? 2.5% solution in a 3-gallon embalming machine. We're going to go ahead and knock out that conversion right now. That's going to give us like 384. And now we have a second variable, Y. Because we don't have an index. Now we have to look at what the question is giving us, and we have to identify what is most relevant. So let's tear this apart. Remember, we have to have 3 of the 4. If we don't have 3 of the 4, we can't solve this. And I promise you, there's probably going to be like an A, B, C, D, E here, and one of the E's is going to be you don't have enough to solve this because they've hidden one of the answers, which is why you want to fill everything in and then go looking. So you have the following index on hand, an 11 index jaundice fluid. So 11 index jaundice. 1, this is low index, and it's a specialty fluid. This is likely going to be inappropriate. This is a no-go. The reason being, it's too low. Even if we were to use it, there is nothing to indicate that this is even remotely supposed to be the right answer because there's no jaundice. So when you're given something like this, that's an immediate red herring. Don't even waste your time. What else do we have? 18 index humectant. This is medium. This is pretty good. With what we're looking at here, we have a male Caucasian decedent, 170 pounds. Well, the weight doesn't really matter. Unless there's something more here, weight really isn't a matter for what type of fluid we're going to use. And 170 pounds, that's about average these days. Exhibits moderate livor mortis. Okay, so the body has had time, probably. So there's one of two ways we can take this, right? Either the body has had time for postmortem hypostasis to occur. The liquid is just flowing into the dependent areas of the body, or maybe they're on blood thinners. It's A or it's B, but chances are pretty good that no matter which one of these we come to, the conclusion is going to be the same. The body should be relatively fresh. What else do we know? Postmortem caloricity shows the body's been dead a minimum of 3 hours. No rigor is evident. So we do know that there has been a relatively short time period between point of death and this moment, and there's no rigor. Well, the next question might, what if we're past the point of rigor? We have primary flaccidity, we have the point of rigor, and then we have secondary flaccidity. Well, if we have moderate livor mortis, body temp shows it's been dead probably about 3 hours and no rigor is evident, chances are pretty good rigor hasn't even been established yet. So everything is kind of pushing you towards the idea that this is a normal case. So this 18 index humectant is pretty good, but remember, we got to look at everything. The next one is a 32 index fast firming. This is a high index, and this is not ideal. I'm not going to say it won't work. I'm simply saying it's not ideal. Why, Professor Finn? There are so many people who reach right for the 32 index. Got to get it done. That's the type of stuff the bodies today wants. The problem is board exam questions are based on the textbook and on the actual science. There is no reason to be reaching for the high index on every single case, because that means you're going in guns blazing. The goal of your job is to have the right tools to do the job. So having a fast firming acid based is probably a good idea for the cases that need that. For everyone else, you might want to have something a bit more generalized. I'm not saying you have to carry the entire chemical catalog of your favorite chemical supplier, but you should probably have at least 3 different chemicals that you use. A couple bottles of the jaundice specialty fluid in case you need it. Maybe 1 or 2 medium index fluids with different built-in dyes for different skin tones, and that one go-to get it done high index for those cases that require that. So this 32 index fast firming is not ideal for this type of question. Again, you can talk about that in the comments, but really for board exams, this is the type of stuff that they're probably going to be looking for. Don't go in guns blazing. And the last one is 22 index. And if you're in a hurry, you're like, oh wow, this is pretty good. This is medium index. Yeah, this is a little bit better than the 18. We could use this one. The problem is it's a cavity fluid. Well, Professor Finn, the book says that in a pinch you can go ahead and you can use cavity fluids. Well, you're right. The book does say that. The problem is, if you're in a pinch, and you're not in a pinch if you have other stuff on the shelf that you can use. The second thing is, in modern day, just about every embalming machine you purchase comes with a big sticker on the front of it that says, do not pour cavity fluid or carbolic acid solutions in the machine. It will void the warranty. So you have very good reasons not to use cavity fluid. And this is a quite common thing. They throw the right number up there. If we had a choice between an 18 and a 22, now we're getting into the area of public opinion. However, they're telling you it's a cavity fluid. Wrong tool for the wrong job completely. So we have to limit our discussion to the 3 that work. We know the jaundice fluid is out automatically, waste of time, don't even think about it. Do we use the 18 or the 32? And there is nothing in the question to show us that the fast firming is a necessity here. That might change if we say something along the lines of like, oh, well, the body's been dead at least 30 hours and has gone through the period of rigor and shows some light signs of decomposition. Yeah, now you can go in guns blazing because the 18 index humectant is probably a bad idea because you have signs of decomposition. But everything tells us that this is likely the ideal solution to be using. So we're going to work off of that. Now, one very important thing that you are allowed to comment on your board exams, okay? Chances are pretty good that even if you comment and say, well, 32 index is going to get the job done better, we're just going to say, no, it's not ideal for this type of case. So make sure you're choosing something that goes with what you're being taught in school, what the book has said. So in this case, we're going to use the 18%. So now we solve for our x, right? Got some lag on the computer. I apologize for that. Whoops, don't want to add those things together. I want to multiply those things together. Got some weird things going on. 9.6. Now we are going to solve for x. And we have an x of 53.33333333. Wonderful. We need 53.33333 bottles. And the answer is no. No, we don't. We need 53.3 ounces. So what this requires us to do to answer the question is one more conversion. We need to divide this number into 16. We're looking at 3.3 something bottles. So let's do the math and make sure this works. We know that this side times this side should give us 9.6. We know that this times that should give us 9.6. The numbers add up. The math is good. So 53.3 ounces, we convert this to bottles, and we look for the 3.33, 3.34, 3 1/3, whatever they have on here. This closest represents the number that we're seeing. So here you see one of those areas where you are running into a situation that you do have to put in some public opinion, but realistically, there is not a lot of opinion here. It is a bona fide fact that if you have a normal body, the medium index is going to be best, unless you have to go with something higher because there is a condition that tells you, and being dead about 3 hours does not necessitate you reach for the nuclear option immediately. So let's go ahead and look at the final question. All right, last one. Did have to stop for a second and go ahead and redo the screen, so there might be a little bit of a shift. Apologize for that. Let's look at this last question. You're preparing to embalm a female Caucasian decedent who is 120 pounds and exhibits no livor mortis. I've noticed I've spelled exhibits wrong in all the questions. I'm just not going to go back and re-edit the video. Just have, it happens. Post-mortem caloricity reflects a temperature of 96.3 degrees. So we have lots of data, lots of distractors. No rigor is evident. Again, maybe this is wrong, maybe it's not. What are we being asked for? How many gallons would you need to create a 2% total? Okay, so we know we're looking for a tank volume. So starting with the tank volume, what other numbers do we have? Do we have everything that we need? It says using 3 bottles, so we're going to do the 3 times 16 of an 18 index solution. How many gallons would you need to create a 2% total? So we're doing pretty good here. Not a lot for us to pick through, so let's go ahead and run the math. Make this nice and easy. This number times this number. This one's turning about the easiest one yet. You're saying, yeah, why is this one last? Well, let's take a look why here. This is going to be the sum of this one times this. Whoops. That was interesting. That cell divided by 2. And we're going to convert that to gallons. So let's double check our math just to make sure. Some of you might already have caught what's happened here. So let's run it just to make sure. This is why we check the math. This times this. This number, yeah, likes doing this to me all of a sudden. Gotta love the old lag on a wireless keyboard. That number times this number. Oh boy, the math doesn't add up. Now this likely is doing this intentionally. This is a common mistake people make, which is why we're saving this here. Here are some problems people do. So the issue is, this is not a 2x. This is a 0.02x. And that was the problem, is wrong number in the wrong place. Remember, like for like. So now we're going to adjust that, right? We're going to do a 0.02 right here. And the math is now right. Now we can just put our 8.64 gallons up here, and away we go. But you say, Professor Finn, wait a second. What's going on here? Well, we have a bunch of numbers. The math adds up, right? X equals 432, so it's not 8.64 gallons. Another common mistake people make. They take the wrong number because they're double checking the math, and they go, oh, here it is, and they click the wrong thing inadvertently. We know it's 432 gallons. And once again, we have a problem. It's not 432 gallons, it's 432 ounces. So we do need to do one last conversion, which is this number divided by 128, which is 3.375. So our answer is 3.375 gallons. So what is ways people can screw this up even after they've done it right? Well, we've already seen that if you decide, let's not do a sum, let's just do a reference here, because we're going to do this 3 times. That if you take this number and you inadvertently divide that number by the wrong thing, you have math incorrect. You have a 2 instead of 2. So we know that that's wrong. Then what some people might do, which is even worse, because you've gotten the right answer, now this goes back and it causes you to have some self-doubt. This is why you check your math. Is you might do something along the lines of this number. Oops. Keep screwing this up here. This number, no more lag, lag needs to stop, times your 3.375. And you get something completely wacky. Well, remember here, folks, the issue you're going to run into is like for like. You've used gallons instead of ounces. So when you are finished, when you have derived your x, the moral of the story is put the x in and make sure the math works. And that's real easy to determine. Whoops, don't want to do that. I want to do that here. The sum of this number, whoops, keep forgetting those parentheses on this last one, times this number. So we know at this point the math is correct, and all you have to do is make sure that you don't answer 432 gallons, that you do that last minute conversion. If you do answer the question right, well, make sure that when you are doing these things that you are using the right numbers to double check the math, which is why I strongly recommend that once you've solved for the x, take the x, put the x back in, run the math, and make sure left equals right. At least you can determine at that point if you do anything else south, it's because you're doing an incorrect conversion or you're using something else that's wrong. At this point, you know that everything you've done is right. So you find the 3.375, you click, you move on to the next thing. Now, the embalming dilution formula is the subject of some debate and we're not going to get into the debate of it because this is the most simplistic and easiest way to explain it. And the primary teaching textbook that is on the market as of 2020 is the Embalming Theory, History, and Practice by Robert G. Mayer. A new edition is coming out. And it does not go into some of the subtle difficulty or subtle changes as to why the number might be right, why the number might be wrong, and your board exam is not going to inquire upon those. If you want to know more about, why is it right, why is it wrong, those sort of things, we'll be happy to make another video about this. But for explaining the actual formula, this is how the formula works. This is all you have to do for your boards. The last thing, folks, is the good news is if you can read the question, okay, if you can read the question, you can brute force the math every single time by simply putting in the right numbers until something comes out, remotely close. Now, unfortunately, you're having to do this longhand. But the brute force method works just fine. You'd have a harder time doing it, say, on a question like this, because the math is likely going to check out with all 4 of the numbers. But chances are pretty good with a no extra variable sort of thing. As long as you're using the right number, you're going to get the math right. And the good news is they're going to give you one side of the equation for free. So you just have to figure out the other side, which math is going to equal something close. And after you've done your initial computation, chances are pretty good you're going to be able to narrow that down to one or another. So folks, hope you have found this informative. Please feel free to like, share, and subscribe and pass along the channel to other people. Go ahead and comment on something else you'd like me to talk about down here on YouTube in the comments section, or maybe in one of the other social media avenues that I have, and I'll be happy to make a video for you. So this is Professor Finn signing off. I'll see you next time.